In this session, we are going to implement or design trie. This is LitCode problem 208. Implement trie. Trie is also generally known as prefix tree. This is a medium-sized problem and the problem description is given here. Let us walk into it. A trie, pronounced as try and followed by e or a prefix tree, is a data structure used to efficiently store and retrieve keys in a dataset of strings. There are various applications of this data structure such as autocomplete and spell checker. During the course later, we will also implement autocomplete facility and spell checker as appropriate. For now, we'll start with building the basic structure of trie. Implement the trie class. So we are going to have a trie constructor and that's going to initialize the trie object. Then we are going to have basic trie operations, insert, search, and start with some character or prefix. Insert function takes a parameter string word that inserts string word into the trie. And then we have the search function that takes a parameter string word. It returns boolean, which means search attempts to search the word, passes an input parameter, and if found, it returns true, otherwise false. And we have the third function that needs to be implemented as part of this exercise, that is starts to. It takes a prefix. Basically, we are required to find if the prefix is part of the word available in the trie. Return true if there is previously inserted string word has prefix, otherwise false. So these are the implementation functions required. There's an example given here. Goes with bunch of operations, try, insert, search as we have defined here, and the data goes in as an apple, app, and so on. So the explanation is like this. The attempt is to make a try object with a constructor and then make an insert, then search for apple, search for app, verify if there is a prefix in any of the existing words in the try, and so on. The constraints are with word length and prefix length. It's somewhere in between 1 and 2000. Word and prefix consist of only lowercase English letters, so we don't need to verify if it's uppercase or lowercase or any other stuff. At most, 3 into 10 power 4 calls in total will be made to insert, search, and touch. That's it. So let's go ahead and implement these four operations and verify the working behavior of a trie data structure. Before we start coding or implementing the trie data structure and its functional operations, we will take a look into the definition provided here. I'll just click it and that takes me to Wikipedia. So we have the structure that looks like, and each node in a trie comprises of children, and to date or define end of the branch, we will need to have a marker, that is a character or a value that determines if the branch is continuing or ending thereafter. Further, we'll jump into VS Code and start defining our trie data structure followed by the operations as dictated by LeetCode. So we are expected to define four functions, including the constructor or object instantiation, and then we will invoke that in the driver and see the working behavior of trie or prefix tree. Now, just before we jump into the implementation, we'll take a look into the example provided by me. So here is an example. We can insert word apple and search for word app and also attempt to insert app and then search for word. Initially, the root is empty. This is going to be a handle to the trie node. The trie node definition goes like this. It's a structure with children of map rune to trie node. So there's going to be about 26 children nodes because we are going to have characters A to Z that's expected to be inserted as each trie node over here. And to represent end of the word, we are going to have a marker. So I'm just going to call it as recent variable. And that's going to indicate if the trie node is end of the word or not. It's going to be true if it is end of the word, otherwise false. We'll take a look at the example. So now if we are required to insert apple after instantiation of the trie node or trie, we'll begin with node like this. So this is going to be A. And A is going to be child of string at level 1. I'll call it as level 1 here externally. Next comes second character in word apple, which is so here I'm further required to insert another trie node at the next level. So we're going to have A, B here. And that's going to be again pointing to the parent trie node. So we have A, P, and next third character is again up. So we are going to insert P to the child of P, and again we are going to have direction like this. So this is level 1. Next we are going to have level 2 where we have P here, and further this is going to be level 3. Our word apple is not yet over, so we are proceeding with L. So let's go ahead and insert the child at level 4. That's going to be like, so I'm going to have level 4 over here. And that's going to be inserted right like this. Further, I have E that needs to be inserted, and that's going to be the last character of word apple. Let me mark E here and then connect it with its parent. At level 5, I have the word that is complete, APPLE. Now, to indicate that the word is complete, we're going to mark this node as a special node. So here I'm going to color it a little different, maybe like this, and then I'm going to mark it with a different color as well. So the ESENT value here is going to be 2 for this trie node. For other nodes, it's all 0. Now, word that I'm going to insert into this trie is going to have its first character begin at level 1. Say, for example, I'm going to insert a word tree. Then I'm going to have the first character of tree like this, which is going to be T. And then it's going to be pointing like this. Next, I'll have R. That's going to be the second character at second level. So it's going to be what we have E and E. So we're going to insert E and E respectively at third and fourth level. So we're going to have like, finally we are going to have three ending here. And so we mark it with a different color. Also shade it up like this to indicate that it is the last character of word tree that we have attempted to insert. So you're going to have tree inserted into the try, also apple inserted into the try. Further, we could insert more words into the try, and every word, as I mentioned, will have its first character at level 1. Insertion of apple and tree. If we attempt to search apple in the try that we have created, the result should be true because we have A here, P here, P here, L here, and finally E, which is marking end of character, and therefore word apple exists in the tree. However, the next search, which attempts to search for APP, will give a different result, not true but the same false, though we have APP here in try. The last character of APP here is not the end of word APP or previously not been indicated as a word during our insert operation. Therefore, it returns false. Search starts with just look for the characters in the try branch, but not specifically look for the marker. So it just search for APP, and because APP exists, irrespective of the status of the marker, whether it is true or false, it returns. Now we attempt to insert APP. In this case, what happens is we could go ahead and insert A here and then make that as a child of. Also now attempt to increase insert so APP is like this. Okay. Now further insert P. And because P is the last character of word APP, we mark this as end. Now there's a catch that we would be interested to observe. Makes no sense. Insert APP a duplicate time when APP is already existing in the alternate. So what we do is we just search for A in the level 1, exists, okay. We search for P in level 2, yes it. Then in level 3, it also exists. So we stop here and then mark APP as a new word. So we don't basically attempt to perform this operation of creating a new branch to the right. Finally, when we attempt to search APP, this time it returns true, unlike the previous time where it returned false because the word APP did not exist. And this shows the basic implementation of try by visual walkthrough. We are now going to create a simple try or prefix tree in VS Code. So let us now begin with package main. And as usual, we are going to import FMT for sake of printing and logging messages. You're going to call upon the driver for try. That's going to be function main. Here we are going to invoke the constructor and corresponding operations related to try for insertion and search. So we'll keep this with fmt.println calling main. Okay. Now we are good to define try and create the constructor. So by definition, we know that a trie node comprises of children that can hold a map of characters for every trie node. That's going to be like this. Type trie node, and that's going to be a structure. We're going to have children, map of rune with trie node. To indicate end of the word, we are going to have a marker. I call it as is end, and that's going to be bool. This gives the definition of trie node. I'm going to add a comment here. Definition of trie node. Next, we are going to have a handle to the trie node, which is going to be the root. So I'm going to say type trie of truck and root to the parent trie node. That's it. We are now going to initiate or build the constructor that's going to help us with instantiating the trie object. To instantiate the trie object. So we will define function constructor here that takes no parameter but returns the trie object. Okay. So we are going to return trie object and that holds the pointer to the trie node that is root. Let us initialize trie node here and instead of being null, we are going to create the trie node here. So let's say trie node, instantiate that, and the trie node comprises of children is end variable. So we'll initialize the children also, and that's done with make utility. So going to say make of map and is end is initially going to be false for every trie node that we are creating. So this is how we are building the constructor or instantiating the trie object. Now we proceed with building the insert operation. The insert operation essentially insert the given word into the trie with each character in the word showing up at different levels of the trie just as we discussed in the try run. So we need to traverse over the string from index 0 to end of the string and pull up each character in form of rune and insert it into the trie at different level, starting from level 1. Let's build that now. Insert the input string into the trie. So we define function this star trie is the object and insert word string. And here we go with implementing the insert operation. So initially we are going to have node that's going to be this dot root, and for every character in the input string word we are going to traverse. So we begin with empty index with each character ch, a range loop over word, and if the character is already available at the given level, then we don't create a new node. If it's not available, then we create a new node. So a new node is created. The character does not exist at a given level in the trie. If the character of the word at a given time does not exist, we create a new node, new trie node. So we find if it's existing or not with the checker node.children for the given character ch. If not okay, then we create the node. Node.children at given character equal to trie node. We implement the same thing as we did here. That is, we create the node. And then node becomes node.children for the next iteration. Once when we are done with this, we say node.esend equal to true for the last character in the input string word. That's it. So we are done with implementing the insert operator. Further, we are going to implement the search operation of a given input string across trie. The approach implemented will be to walk over the trie from level 1 to level n over the string from index 0 to len of the string, and if the character at a given level is not found, we return false, otherwise we continue until end of string is approached. And the node at which end of string is approached should turn out to be true to indicate that the word has been inserted or is available in the trie. So let's go ahead and implement it. I'm going to say search. This is a lookup operation, lookup for a string in the trie. So if we have previously inserted into the trie, we find the given input string and we return true, otherwise false. So to implement that, we are going to define search, and that will be across object trie, search, word, string, and the return value will be boolean. We say true or false depending upon the availability of the string. So we initialize node here to this dot root, and we traverse across the word in range loop. So for ch in range of word, if found, continue, otherwise return false. Node dot children of ch, if not found, return false. Else node equal to node dot children of ch. Now return node dot send if all the characters in the input string are processed. We don't need this else statement, we just leave it as it is, so it will be processed accordingly. Okay, so we are done with implementing the search function. The next function that we are going to implement is the starts with function. Start with function attempts to identify prefix string in the trie. So basically, it has a prefix word and it is looked upon to verify if the prefix is available as part of any word available in the trie. If it is available, the function returns true, otherwise false. It is in the same lines as we had implemented the search function here, but the only catch is starts with function doesn't expect verification of the recent character. All the characters in the prefix are available in the trie according to the level that it walks through, it simply returns true. It doesn't verify the recent state as such. So we are just going to mimic the search function. So start with going to verify if prefix is available as part of any word in the trie. So all that it does is we just take this function, and the only change here is we return true if we have walked through the string successfully, and this is going to be prefix string, and this is going to be starts with. Okay. So I'll keep this uppercase search and insert also as uppercase. Okay, we are done with implementing that one. We need to walk through the prefix string. That's it. Final piece that is left over in implementation of trie data structure is filling up the driver for the implementation. So let us go and complete it by closing up the scaffolding. We need to instantiate the object with the constructor that we had created, and then call upon the trie operations with the trie object the handler. So now I'm going to call trie.insert. I'm going to insert apple and then I'll say fmt.println. I'll say trie.search apple. So this should return true. Next, we'll perform same thing fmt.println. Search for app instead of apple. It should return false. Next, we will insert app as a word completely and make an attempt to search that. In that case, it should return fmt.println try.search app. Now this should return. Finally, we can have start with function also called here fmt.println and that will call try.start with. And before we are inserting app, we can look for app here and it should return true. Because app is part of Apple and it should return true. Only that app word hasn't been inserted until it's implicitly inserted here. So we'll save this. We can go ahead and attempt execution. I'll jump into the corresponding folder system.design. Yeah, now I will run this. Try it. So the expectation is to show up true, false, true, 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 false, true, true. Perfect. It's working as expected. We can now also make an attempt to insert another word, tree, into the try. So I'm just going to try that now. So let's add tree here. And if I search for tree, it should return true. However, if I search for tree, it should return false. Okay, let me clear this and rerun it. True, false, true, 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 false. Perfect. It's working as expected. So with this, we have implemented the basic functionalities of trie data structure and we can pull up this into our late code problem and look into the execution. Let us jump into late code right away. So we need to have the trie data structure, constructor, insert, search, and start with function. This is starts with. So let us pull up this. I'm going to close this and take all of this. Insert it here. This should be starts with as expected. Okay. So we are good to run this. We'll see the console. The test case is going as we had seen in this example here. I'm going to minimize this window. Okay, you're good to run. Awesome. Fantastic. So we have implemented it perfectly with the minimal test cases that was attempted during the run. We can also go ahead and submit so that we see additional test cases as called out by corner cases by lead code also gets executed. So let's submit. That is also as perfect. All right. With this, we are done with the implementation of trie data structure with basic trie operations.